This lesson is on the rational zero theorem. So up to this point, when we have tried to find the zeros of some sort of polynomial, it's either been something we could factor, or they have given us a factor or given us a zero, and now they're not going to be so nice. So we are going to use something called the rational zero theorem to know what all of the possibilities are for zeros for our polynomial function. Now, bear with me a little bit with all of the notation that's happening here. What this is saying is you have a polynomial function. This is a sub n, which means it's your first coefficient, and then x to the n. So let's say this is the to the fifth degree. So this would be a sub 5, which just means the coefficient in front of your n or x to the fifth term, etc. So what we're really concerned about here is our polynomial in the correct standard form, meaning that notice it's decreasing by 1, and at the end we don't even have an x anymore, we just have a constant. That's what we're looking for. So if it's in standard form, I'm worried about this first term and this last term for the rational zero theorem. Those are the two that I'm using. So what we're looking for here are we're looking for p, which are factors of this last term, and q, which are factors of this first term. So they're numbers that multiply into that. And if we take the quotient of those, if we make a ratio out of those factors, that will give us a list of all of the possible factors, or all of the possible zeros of this polynomial. So here's what I mean by that. Let's find factors of p, and let's find factors of q. So in our case, p, which is the constant term, is 15 or negative 15. So the factors would be plus or minus 1, plus or minus not 2 because 2 doesn't go into 15, plus or minus 3. 4 doesn't go into 15, but 5 does. 6 does not, 7 does not, 8, 9, etc., all the way up to 15. So basically I'm saying all of the things that multiply into 15, I'm listing them here with both a plus and a minus. Then I look at factors of q. Q in this case is 4. I'm looking for factors of that. So what numbers go into 4? 1, 2, and 4. So all of my possible zeros are any of the different combinations I can make using this. So I could have plus or minus 1 over 1, which is plus or minus 1. I could have plus or minus 3 over 1. I could have plus or minus 5 over 1. I could have plus or minus 15 over 1. Let's repeat the process for 2. Plus or minus 1 over 2. That's a half. Plus or minus 3 over 2. That's 3 halves. Just leave it 3 halves. Plus or minus 5 over 2. And plus or minus 15 over 2. Then I could have plus or minus 1 over 4. I could have plus or minus 3 over 4. I could have plus or minus 5 over 4. And I could have plus or minus 15 over 4. So we should be a little bit scared at this point because this is a lot of things to check. So what we're saying here is that we would just have to start checking these and plugging them in to see if there was a remainder of 0 in order to be able to solve this polynomial. Later I'll show you how to sort of pare it down a little bit, but really that's what we're going to do is you're just going to pick one. You're going to plug it into your calculator. So this is where that plugging it in rather than doing synthetic division every time will really save us some time. For now, all we're doing is we're listing the possible zeros. So here is a list of all the possible zeros. Notice these are all plus or minus. So that means it's not just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 options. It's actually 24 different options. Okay, and I know there's only going to be 3 of them that work, but there's 24 possibilities that I might have to check. For this question, I would like you to find all of the possible rational zeros on your own and then press play to check your work. Remember, right now we're not actually plugging them back in, we're just listing. So go ahead and do that and then press play. So again, I'm going to be focused on the 8 and on the -4. So the factors of 8 would be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Factors of -4 would be plus or minus 1, plus or minus 2, plus or minus 4. So my possible zeros would be 1 over 1, which is plus or minus 1, 2 over 1, 4 over 1, and 8 over 1. It could also be 1 over 2, 2 over 2, which reduces to 1, and I've already listed 1, 4 over 2, which reduces to 2, and I've already listed 2, and then 8 over 2, which reduces to 4, and I've already listed 4. Then it could be 1 over 4. It could be 2 over 4, which reduces to 1/2, and I already have that one. It could be 4 over 4, which reduces to 1, which I already have. And it could be 8 over 4, which reduces to 2, which I already have. So here's my possible zeros, and that's all I had to do for this question. Now that we've had a chance to practice what the possible rational zeros are, now we have to put it to work. So now I have this polynomial, and my job is to find the zeros and their multiplicities. So to find the zeros means I have to factor this down as much as possible, and I can't factor something that has 5 terms. And so this is where I'm going to use my rational zero theorem. So factors of 3 are 1 and 3. Oops. Factors of 2 are plus or minus 1, plus or minus 2. So my possibilities are 1 over 1, 3 over 1, 1 over 2, and 3 over 2. So notice that I was nice to you on this one. There's only 8 possibilities. So now what I'm going to do is I'm just basically going to choose any of those 8 possibilities, either positive 1, negative 1, positive 3, negative 3, etc. And I'm just going to plug it in for x. So let's try f of 3 and see what happens. And I find when I plug in 3 that I get 144. So if I don't get 0, I just keep trying. So I didn't get a 0 here. So now let's try, say, -3. Now for the sake of room and space, I'm not going to write out all my work. I'm going to plug it into my calculator and find the solution. When I plugged in -3, I found 90, which is still not 0, so I'm not doing very well. I'm going to try plugging in 1, because I'm trying to avoid plugging in fractions, obviously. So I'm going to try plugging in 1. And when I plug in 1, I do get 0, which makes me very happy, because now I know that if I plug in 1, that it goes in evenly, which means now I'm going to take 1, and I'm going to divide that by synthetic division into my function. So 2, 1, -5, -1, 3. I bring down the 2, multiply, add, multiply, add, multiply, add, multiply, add, which means I'm left with 2x cubed plus 3x squared minus 2x minus 3 equals 0. Once I get it to the point that I might be able to factor, I'll probably do that instead of continuing to guess and check, because that's sort of a tedious process. So from here, I see that I have 4 terms, and it looks like I'm going to be able to factor this by grouping, which makes me really happy because that's less work. So I know that one of my solutions is 1, so don't forget that when we get to the end of this question. If I factored this, I would take out an x squared, which would give me 2x plus 3. If I took a GCF out of these 2 terms, I would take out a minus 1, which would leave me with 2x plus 3, which leaves me with x squared minus 1, 2x plus 3. This factors into x plus 1, x minus 1, 2x plus 3. So from here, I need to write my factors and I need to write my zeros. So my factors are using the 1 that I came up with at the beginning, which would of course be x minus 1, because we're always subtracting, and then x plus 1, and then, oh look, another x minus 1, so that's x minus 1 squared. So when it's talking about that multiplicity, that's a multiplicity of 2. And then 2x plus 3. Those are my factors. My zeros are setting x minus 1 equal to 0, which means positive 1, but that has a multiplicity of 2 because this was a squared. X plus 1, which gives me negative 1, and then 2x plus 3 equal to 0 gives me negative 3 halves. So those are my zeros. Here's my factors, here's my zeros. Go ahead and try this one on your own, and then press play to check your work. So again, I'm going to start by looking at factoring by grouping because it just has 4 terms, and it becomes very clear very quickly that this is not going to factor by grouping. So I'm going to look at my PQs. Factors of 5 are plus or minus 1, plus or minus 5. Factors of 1, those always make me really happy, are just plus or minus 1. So my only choices that I can plug in are 1 over 1 and 5 over 1. So that means I only have 4 different options for plugging them in. Now keep in mind that's only going to give me a real solution, so there could be imaginary solutions that I'll find as I'm working. So I'm just going to choose, say, 5 and plug that in and see what happens. And I got really lucky because when I plugged in 5, I did get 0. That usually doesn't happen to me. I usually have to try a couple. So I'm going to take my 5 and I'm going to use it for synthetic division. So x to the third, 2x squared, negative 2x squared, negative 14x to the first, and negative 5. And I should end up with 0 in this box. So bring down the 1, 5 times 1, add them together, multiply, add, multiply, add, which means I'm left with x squared, so 1 degree less than the original, plus 3x plus 1 equals 0. So one of my factors was x minus 5. So I used positive 5 here, so it's x minus that. That's one of my factors. Zeros, so far, I've found positive 5. Now I'm going to look at x squared plus 3x plus 1, and that does not appear to factor to me because there are no numbers that multiply to 1 that add to 3, unfortunately. So that means now I'm going to have to use the quadratic formula. So I'm going to say x equals the opposite of b plus or minus the square root of b squared minus 4 times 1 times 1 all over 2a. So that gives me negative 3 plus or minus radical 5 over 2. And depending on how they want me to write my solution, I would probably write this did not factor any further, so that's my factor, that's my factorization. My zeros are 5, and then also both of these, which is negative 3 halves plus radical 5 over 2, and negative 3 halves minus radical 5 over 2, or however they want you to write it. So they might want you to keep the negative 3 plus radical 5 all on top of the fraction. Just pay attention to how Alex wants you to put those in the computer.